61.
That's it. How about E? And now how about D?
D?
Mm-hmm.
Okay. 5. Okay. So 11 squared is 121.
Yep.
Yep.
D.
D? Eleven squared.
So that's B. You did that one. Oh, or D. Yeah. Sorry, go on.
11 squared is 121.
Yes. Sorry, I thought you were doing B. And so, yes, what that shows you is that these two are not the same thing. 5 squared plus 6 squared isn't the same as 5 plus 6 squared. How about E?
I didn't know how to do that.
What times itself gives you 36?
6.
Yes, that's what square root is.
Oh.
It's the opposite of squared. And how about F?
13 times 13.
That's 169.
169, okay. And then 144. Take away from each other is.
Do you know what that is?
24, 25.
Yeah. And so, what is the square root of 25?
5.
Well done. That's it. Okay, any questions there?
Nope.
Okay. Do you have a calculator?
Yeah, I can get it.
Okay, yeah, you'll need it for these.
Okay. Okay, yeah, I've got it.
Okay, so try. Do you know how you would put that first one into the calculator? So square root first.
C. Okay.
So try putting that into the calculator.
Square root. Yeah.
And what do you get?
Let me just put it in. That is 11.
6 squared, take away 5 squared, and then you square root it. So square root of 11.
Square root.
And if you don't have, so did you do 6 squared, take away 5 squared?
Yeah.
And so if you didn't put it in a square root, just press square root, and you can press answer or 11 and see if that works.
Okay. $1.821160.
Okay. I think your one was fine. Let me just check something. Yes, that's good. Okay, so you can do it 2 different ways. You can write it as the square root of 11, or you can write it as a decimal. And for a calculator paper, a lot of the time they'll ask for a decimal, and then for a non-calculator paper, they'll ask for just what it is. So you might have like some number that you can't get a square root for. Okay, let's try this.
Which one of these are right angle triangles? C, F.
There's one more.
A.
Yes. Okay, let's try this. C squared is A squared plus B squared. You have to find what C squared is.
Okay, so A plus B. Okay, and then A squared is how do you square the number on the letter?
So A is 3.
Okay, I understand.
Okay.
So 3 squared is 9. And 4 squared is 24. No, 16.
Yeah. So what do you get there?
You get 25.
Yeah. So C squared is 25. And now part 2, they want what C is. If C squared is 25, then what is C?
5.
And so in this case, it would be a length. Another answer could be -5 because a minus times a minus is a plus. But we're just going to be looking at lengths. And so we'll just be dealing with the positive one. This stuff, I'll just leave it, I think. This is just to prove where this thing comes from. Basically, in a right angled triangle, the two sides around the right angle, if you square them and add them to each other, you get the third side squared. And you can use that to find the third side. So the hypotenuse, the length of the side opposite the right angle, is always the square root of the sum of the square of the other two sides. So square one side, square the other side, add them together, square root it, and you get the third side. We'll practice that.
Okay.
So this is a calculator question. How do we do this?
Calculate the length of XZ. So, wait a minute. So you just have to add 1.35 to 3.25.
You'd square them first.
Square them. So, you have to use your calculator.
Yeah, let's calculate. $12.38500. And okay, so that is that the length of the third side?
Yeah.
That is the length of the third side squared. And so what's the opposite of squared?
Square root.
Yes, and so square root your answer.
Okay.
What do you get?
$3.519233.
So let's say 3.52 meters to 3 sig figures.
It's 1. 3.
So it's because it's it would round to 3.52.
Oh.
And I just rounded it. That's it. So square one side, square the other, add them together, and square root it. And you can always just do it from the start. The hypotenuse is the square root of the other two sides added together. So you can just put it in your calculator like that, in the same way that I did here. Square root, that one's squared. Our one was plus, not minus. Okay, so try this one.
Okay. Okay. So 24.5 squared add 10.6 squared.
Well done.
Okay. 24.5 squared add 10.6 squared. And then you square root the answer.
Mm-hmm.
So the answer is 26.69.
And what does that round to one decimal place?
To 26.7.
So that is very close to being 26.7 centimeters. And you can see how there was one decimal place in the question, and so we've got one decimal place in the answer. 26.7, that's 3 marks. So this is a way to find the third side in a right angled triangle, the length of the third side. Any questions about that?
No.
Okay, you're doing great. Oh, how do we do this one?
Oh. So that it won't get in without bending.
So I won't go the 5 centimeter way, definitely not. And if it's 22.4, then it won't go across. But would you be able to fit it in if you put it in diagonally? So you know the way you might kind of turn it. Try to fit it that way.
Oh.
Could you fit it in that way?
Well, let me see. No.
Well, what length is this red line?
22 centimeters.
I don't think so. Here you have, this is basically a right angle with these two.
Okay.
So that's like 90 degrees with each other. And it makes a triangle if you do that diagonal.
Oh. Okay. So if it's a triangle. Yeah. Yeah, I'll fit diagonal. So,
Mm-hmm.
so would the envelope would be able to fit because it's a triangle?
So how would you find the length of the red line?
You would. You have to find the area of the triangle.
You would use our Pythagoras, square root of 5 squared plus, or square root of a squared plus b squared.
Okay. So 5 squared add 22 squared.
Yep.
Okay. To 22.56.
And so the length of this is 22.56 centimeters. And so will the envelope fit through if you turn it that way?
No,
Why not?
because it's above 22 centimeters.
So how long is the letter?
The letter is 25 centimeters.
So the envelope is 25 and it's 22.4 wide. So you could put it width first. So this one here is roughly 22.6.
Yeah.
And so you could fit something that's 22.4 in there because it's less than it. So that's 22.6. You have something that's 22.4. And so it would be able to fit in if you turn it this way, because it doesn't matter how long it is. You could just keep pushing it through.
Okay.
And so it will work out. And they said you have to show your working, so I'll just show my working. This always works for triangles. Any right angled triangle that you can make, you can find the length of the hypotenuse, the third side opposite the right angle, by doing the other two sides, square them, add them, square root. And that'll work for our right angled triangle. Let's see. Let me think. Maybe I'll just do something. So these are all calculator. So they're always a calculator paper. Yes, so this one. You have to work out the slant height. How would you do that?
Because it's a triangle,
Mm-hmm.
you do hypotenuse. Hypotenuse. Yeah. So you do 9 squared, add 4 squared.
Mm-hmm.
And then you find the square root of your answer.
Mm-hmm.
And the answer is 9.84.
Okay, 9.84 centimeters. Great. So yeah, even though it's a cone, you can see that it makes that thing. This one. How could you find the length of this diagonal arrow?
Find out how many cubes on the top and the sides.
Okay, how many?
1, 2, 3, 4, 5. 1, 2. 4.
So that's 1, 2. So 4 up, is it? 1, 2, 3, 4.
Yeah.
Okay. And how many across?
3.5 across.
I think it's exactly 3. And so try this one non-calculator.
Okay. Come on. So 3 squared add 4 squared. So 3 squared is 9. And 4 squared is 16.
Mm-hmm.
So 9 and 16 is 12. No. 25.
Mm-hmm.
So is that the answer?
That's that side squared. So you can see that's a 3, that's a 4. 25 would be way too long. What do you all have to do with your answer?
On the square root.
Yes.
25.
And so what is the square of 25?
5.
Well done. And so what is the length of that diagonal line?
5 centimeters.
Yeah, and actually we don't know that they're centimeters, but it's just 5 units, whatever it is, 5 squares. Yeah, so it's not obvious. You can see it's, if you go 3 across, 4 up, that one diagonally is 5. Yeah, so you just imagine that it's in a triangle, and you would do the same with all of these. So you just imagine that it's in a triangle, and you did well with that. Any questions there?
Nope.
Do we try one of these ones? Yeah, why not? Okay, how would you do question 5 part A, do you know?
I don't know.
So a vector, have you seen vectors before?
Nope.
I'll just leave that. I'll leave that then. I'll leave this one. Okay, any idea how we do this one?
Total length of 4 sides of the rectangle and its diagonals.
Mm-hmm.
Because it's a rectangle. Wait, so do you still have to use hypotenuse for this one?
So you have to add up all the sides. So what would be, sorry, go on.
9. It'll be 39 on the one opposite 39.
Yeah, so that was 39.
And then on the top is 52.
Yeah.
So then what you can do is you can do 52 add 52 or 52 times 2.
Mm-hmm.
And that is 104.
Yeah.
And then you can do 39 times 2, which is 78.
Mm-hmm.
And then you do 104 at 78, which is 182.
Okay. So that's what you get when you add up those 4. It says, and its diagonals.
Oh.
What do you do next?
I don't know.
So how would you get, so one diagonal is going this way. How would you get the length of that diagonal?
Hypotenuse.
Yeah.
So 39 squared. 39 squared or 52 squared.
Mm-hmm.
39 squared and 52 squared. So when you get the answer, then you find the square root of the answer,
Yep.
which is 65.
And so each diagonal is 65. Okay.
You have to do 65 and 65 times by 4.
There's only two diagonals.
Oh, times by 3, so it will be 130.
Yeah. And so is that the total length of the four sides and the two diagonals?
No. Actually, no, it isn't. So you have to add 182 to 130.
Hold on.
And that is...
It's a calculator question.
That is 312.
312. That's meters. And 312. Oh, 5 marks. That was a big one. So yeah, it's basically 52 plus 39 plus 52 plus 39, because that was the same thing. And you're correct. You could also do 39 times 2 plus 52 times 2. Then you have to do Pythagoras for the hypotenuse. You get 65, and so you add on 65 plus 65, or 65 times 2. Add them all up and you get the answer. Any questions there?
No questions.
Okay, so that's good. So right angle triangle, you square root it. So you square them, square root it. These ones, let me see this one. I think I'll just leave those. I could. Some of this stuff I could. Yeah, I think I'll just do something that comes from this. That's grade 9. So you use this for 3D stuff as well. You'll use that later on. Okay, so how do you feel about that Pythagoras stuff?
Yeah, I understand it.
Okay, so that's you did a 5 marker. I'm happy with that. Okay, how do we make a squared the subject? So that means make it a squared equals.
I don't know.
You would subtract b squared from both sides. So that would leave you with just a squared on the left side. What would be on the right side?
Is it minus b squared?
You had c squared, and so it'll now be c squared minus b squared. In other words, to find the, and then you could, so a is the length of one of the other two sides. And so if you weren't finding the hypotenuse, if you were finding the length of one of the other two sides, it would be hypotenuse squared, take away the other side squared, square root it, and that gives you the other side. So if it isn't a hypotenuse, you do it this way. And you always put the big number first when you're squaring it, because you can't square it negative. And this one, let me see. Okay, let's try this one.
Okay. B, C. Pythagoras. So do you have to do 6 squared and 13 squared?
It is other way around. It is 13 squared, take away 6 squared.
Okay. I think square take away 3 squared. I mean squared.
Mm-hmm.
So then you find the square root of the answer. Then the answer is 11.53.
And so to 3 sig fig, that's like 3 digits.
Oh. 5, 3.
That's 3 decimal places, so we just need 3 digits. So 11 point and then 1 digit more.
Oh, 5.
Yeah, so 11.5 centimeters, and that's 11.5 for 3 marks. So 3 significant figures just means 3 digits. 1, 2, 3, 1, 1, 5. So the normal Pythagoras to find the hypotenuse is a squared plus b squared square root the answer. This one is hypotenuse squared take away other side squared square root the answer. Any questions there?
No.
Okay.
No.
So this is some practice stuff. Calculate. Okay, how do we find the height of the first triangle?
Do you do 3.5 minus, 3.5 squared minus 2.5 squared?
Well done.
Okay. Then get the square root of your answer equals, gives the answer to 1 decimal place, equals 2.4.
So that one is 2.4 centimeters. How about question 2?
Question 2, so you do the same as you did. So 4.5 centimeters squared minus 8 centimeters squared.
If you see this, the triangle on the right, it's just a little triangle. The 4.5 would have to be the whole thing. So you just use the triangle on the right.
It was before.
Yes. So 4.5 squared minus 4 squared.
Okay. 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 So your answer is 2.06.
So let's say 2.1. Because 6 is more than 5.
Yeah.
Any idea how we do question 3?
No idea.
So if you look at it as one big triangle, so imagine it was one big triangle, what would you do?
If it was one big triangle, then I would add 4 centimeters and 3 centimeters, which makes the whole thing 7 centimeters long. And then I do hypotenuse thing. So 8 centimeters squared minus 7 centimeters squared. So then get the square root of your answer.
Well done.
And then, yeah, you get 3.8. 3.9.
3.9, is it?
Yeah.
Okay, 3.9 centimeters. Great. Any questions with that?
No.
Okay, so this can be used to find the height of a triangle. Okay, let's take a look at this one. Exam question.
Okay. Okay, so here follows method to find out the depth of BC. So what you have to do is just how you do it all the time. So 6 centimeters squared at 8 centimeters squared.
Which side is the hypotenuse?
Oh, so we minus.
Yeah, and so what would you do? What
So
minus
then
what?
it'll be 6 centimeters wide minus 8 centimeters squared. Centimeters squared.
Okay, what would you get?
Okay. And when it's not, find the square root of it's minus 28. When you find the square root of it, it's...
Does it give you an error?
Yeah.
That's because it's negative. It should have been 8 squared minus 6 squared. And so it would be positive 28.
Okay. Five point two, boom, 5.2.
Yes, centimeters. And so this is what Sarah did. What mistake did she make? She said the answer was 10.
Yeah.
So it says this pupil Sarah did it this way, but she made a mistake. What mistake did she make?
So today we see here. She did the calculation wrong.
So what did you do? What was your calculations?
I did minus.
What did she do?
She did plus.
So you would say something like that. I mean, working out the correct answer is the best way to do it. But you would say, she did 6 squared plus 8 squared. She should have done 8 squared minus 6 squared. Yeah. Any questions with that?
Nope.
Okay, we're doing okay. Okay, how about this one?
Okay, so here we go. 13 squared minus 5 squared. And the answer to that is 12.
Well done. And so the height is 12 centimeters. Oh, this is tricky stuff. I might leave that. I might come back to it. This is a very good one. Let's do this one.
Oh, okay. Oh, how do you get x?
Is there any blanks you can fill in that might help you? Anything you can discover?
No, I can't see anything.
You could find the length of BD. How could you find the length of BD?
BD. So you do 5 centimeters at 10 centimeters?
No.
Minus.
Yep.
10 centimeters. 10 centimeters squared minus 5 centimeters squared. So 75.
Okay. And so is BD 75 long?
No, you need to get the square root.
Yes.
So the answer is 8.6.
Okay. So I'll just write down that's roughly equal to 8.66. And so how can we use that to get x?
I don't.
Yes.
So you. I don't know.
What side is x in the bottom triangle?
It is on the left.
It's opposite the right angle. What's the name of that side?
The hypotenuse.
Yes. And so how can we find the hypotenuse if we know 8.66 and 4?
Oh, okay, I understand. So you just do, yeah. So you just do 8.66 squared. 8.66 squared. Is it add or minus?
You tell me.
Add.
Yep, add, because we're trying to find the hypotenuse. And actually, with your calculator, it might be better to use the answer key instead of 8.66. So if you do answer squared, do you see where the answer button is?
Yeah.
Yeah, so that might be, because then you'll get it all the digits, 8.66, 0235, whatever they were. So it'll be more accurate.
Okay. And then add 4 squared.
Mm-hmm.
So 9.5.
They want 2 decimal places.
9.53.
And is that closest to 9.53?
Yeah.
I believe it's closer to 9.54 because the number after it is 9. So
Okay.
it's very close to 9.54. centimeters. Yes. So maybe we need to work on rounding a bit. That one's okay. Sorry. Any questions about? Oh, sorry. This was a good question because you had to use the minus type and then you had to use the plus type. So the minus type is when you have the hypotenuse. The plus type is when you want to find out the hypotenuse. So any right angled triangle, it's either going to be the square root of a squared plus b squared, or it's going to be the square root of c squared minus b squared. And you can use those two. So minus when you want the hypotenuse, minus when you have the hypotenuse, plus when you want the hypotenuse. Any questions about that?
No, it's just...
Okay. So minus have hypotenuse. Okay. This one is a tricky one. Let's see these. Those are okay. Same idea. Okay, how do you feel about those?
Yeah, that's good.
Okay, so in general, Pythagoras. Oops. In general, so when do you use Pythagoras?
When there's a triangle, right angle triangle.
Yes, right angle triangle. And what do you when do you use it with a right angle triangle?
When you're measuring the third line.
And so it's when you've got two sides and you want the third side. When do you use the plus type Pythagoras?
When you when it's a right angled, like,
yeah, so right angle triangle. You use minus type for right angled as well. When's the only time you use plus type?
When you're trying to find the third side.
Which is the third side?
XZ.
What's the name of it in general? Not just this one. What's the special name for that third side?
AB.
Nope. Even more general. Has a special name.
C.
Starts with a H.
Hypotenuse.
Yes. Sounds like hippopotamus. If you want, so this one we didn't know what the hypotenuse was. That was the mystery number, and so we had to use the plus type. When do we use the minus type?
When you know the hypotenuse.
Correct, and you want to get one of the other two sides. So Pythagoras is when you have two sides and you want the third one, and it's used any diagonal line of any kind. So you can use it for these diagonal lines in a triangle. Hang on, did I skip? No. So any diagonal line, you can use it to find the slant height of a cone because that's a diagonal line. You can use it to find the magnitude of a vector because that's a diagonal line. You can use it to find literally just the length of a diagonal line, that, because you can just imagine that there's a triangle there. Any diagonal line, you can find its length by using Pythagoras. Square root of a squared plus b squared. Yes, so I want to, the very first digit is the tens.
Yeah.
4 tens. So you have to round that to the nearest 10. So that rounded to the nearest 10.
So it will be 40.
Yes, well done. How about one underneath?
It will be 20.
Yes, brilliant. And then this one is to 4 decimal places. So that's a weird one.
So 4.5800.
580. So this one is the one we'll be rounding. That's the fourth decimal place. 1, 2, 3, 4. What is the number after it? What way will that make it round?
So it will be 1.
Yes. So 4.5801. You have to add 1 to it because that one's 5 or more. So you always look at the number after it. Any idea how you do the top question?
You just do the equation.
Estimate.
Estimate. So guess.
It has a specific meaning in maths. It means round the working out to one significant figure.
Okay.
And
So
what will that be?
on the thing. So round the first one to a significant figure. So 19 would be 20.
Yeah.
And 210 would be 200.
And that's 200. And so what is the answer?
So times it by 10, then times it by 2.
Yeah.
It'll be 4,000.
Well done. That's it. So estimate means round the working out to one significant figure, and then you solve it from there. Okay, how about the next one?
So it'll be 31 times.
31 has 2 figures. We want just one that isn't 0.
So it'll just be 30.
Yeah.
And then it will be 10.
Yeah.
And then it will just be 300.
Okay, so 300 is on the top. What is on the bottom?
1.
To one significant figure is the first digit that isn't 0, and so that's the 5, and so you're rounding it to the nearest 1 decimal point.
So it will just be 5.
It would be 0.5.
Yeah.
If it was money, that would be like 50p. It wouldn't be £5. Do you know how you divide by a half? How many halves are in 300?
600.
Well done. Effectively, you just double it because there's twice as many ones because they're half the size. Very similar one. How about the one on the bottom?
That is. So it would be 90 times 0.5. So it would be 45.
Yeah.
And then on the bottom would be 5.
Yeah.
And then it would be 9.
Well done. Well done. Great. Round the working out to one significant figure and then go from there. Any questions about that one?
No.
Okay. And so do you have your 12 plus exam? Do you know when that is?
Yeah, in like after the summer break.
Okay. So we're okay. And Pythagoras, yeah, these are good. Estimate. Okay. How'd you find that?
Good.
Okay. Anything in particular you want to do next time, or should I pick?
You can pick.
Okay. And any questions for me in general?
No.
All right. Well done, Carlos. You did great. I look forward to talking again next week.
Yes.
All
Goodbye.
right. Have a good week. Goodbye.